welcome to this presentation. My name is Enrique Garcia, and I'm going to talk about robot kinematics. The humanity's development has always been linked to the creation of tools and techniques to improve their standard of living. One of these tools is robotics, because the knowledge of robotics comes from several fields of engineering, for example, electronics, electrical, and physics. A robot is a mechanism that moves automatically. So in order to study its movement, we need to use mathematical models in order to control it by using the study of kinematics. In this presentation, I'm going to talk about the components of a kinematic model and then explain the three main types of kinematic models: forward kinematics, inverse kinematics, and differential kinematics. In the end of the presentation, there will be a series of conclusions. In order to develop a kinematic model, it is necessary to obtain a series of variables and data from the robot and then perform the operations in order to obtain a mathematical model which interprets the robot's movement. Firstly, the position and the displacement must be identified through the Cartesian coordinates and the displacement vectors, which are defined by rotational movement and linear movement. There are four methods for determining the rotation movement: rotation matrices, Euler angles, including roll, pitch, and yaw, fixed angles, and quaternions. We can talk about a specialization process in which we can use one method or another depending on the field of the study. For example, Euler's angles are the most widely used in aeronautical engineering, and quaternions are most commonly used in computer engineering to generate models, for example. The robot's movement consists of translational movement and rotational movement, which are related in the homogeneous transformation matrix. A mathematical model that consists of a set of movements with various translations or rotations. We can use the homogeneous coordinates that put the robot's position vectors in a column matrix. We have already know the elements and calculations that we have to carry out in a kinematic model, but we have to keep in mind the initial data we have collected and the morphology of the robot in order to select the correct model to use. These three models are forward kinematics, inverse kinematics, and differential kinematics. First, the forward kinematic model obtains the gripper position from the coordinates of the joints, and this depends on the degrees of freedom that the robot has. There are two methods to carry out this model: the geometric method and the Denavich-Hatten method. The geometric method consists of analyzing the links of the robot through geometric relationships, which is best for robots with 3 degrees of freedom. And the Denavich-Hatten method consists of obtaining the transformation matrix of the time kinematic chain of the robot link by link. We can use the following steps. 1. List the links. 2. List the joints. 3. Locate the origin of the reference systems and place the reference exits in each link using calculations until reach the gripper. And 4. Fill in a table relating the number of links to its distance and turning angles. After filling this table, the values obtained must be related to the transformation matrix A. By the entire rotation values of the joints, the final position of the gripper is obtained. Next, the inverse kinematics model allows us to find the values that the joint the required coordinates to the gripper position in a certain point in space. This method does not provide a single solution for the time movement, but rather a closed solution for each moment. There are two approaches, the geometric method and the numerical method. The geometric method is similar to forward kinematics, and the numerical method can be carried out in two ways. The first is by using the inverse of Denavich-Hattenberg method, and the second method requires eliminate variables from the transformation matrix in order to find the joint coordinates. And lastly, the kinematic modeling of a robot looks at the relationships between the joint variables and the position and rotation of the gripper, in which the force acting of the robot are not taken in account. However, the relationship between the joint coordinates and their respective derivatives must be known because the robot control system establishes the space that is must print in each joint. For this, we can use the Jacobian matrix to establish this relationship. There are two types, the forward Jacobian matrix and the inverse Jacobian matrix. And to conclude, I want to emphasize that in the study of robotics kinematics, it's essential to know how the robot is configured, what element it has, and what its possibilities of movement are. With this premise, you can calculate what do you need using one of the models that I have previously defined: the forward kinematics, the inverse kinematics, and the differential kinematics. And this is all. Thank you for listening.